In this video, we will be finding the domain and the equation of the asymptotes for these trig functions. So we were kind of looking at these different trig functions, and I kind of gave you the domain of these guys. The only thing is that when you're looking at the domain, sometimes it will be really difficult to find if the insides were something completely different. So this is kind of what I did in the previous videos. I told you what the domains were. You can kind of see it in the graphs. But now if I were to change it without having to graph it, because you can see that graphing can take a little bit of a while, how can I find the domain of the function without having to graph it? Okay, so this is how you would do it. So all you have to do is whatever is in the inside, all you have to do is just plug it into the x value and then just solve for the value of x. That's all you have to do. Now, the only thing to kind of just be careful with is your algebra has to be pretty good. The algebra problems are not going to be as bad, but you do need to be really good with the fractions. So either know how to find the lowest common denominator or know how to use your calculator very well. The way that I remember it is that the c's, cotangent and cosecant, have the same domain, not equal to pi k. The other ones, which are the oddballs, have the pi over 2 plus pi k. They like to be extra. Okay, so now how do we find the equations of the asymptotes or the domain? All you really have to do is whatever's in the inside. Look at the inside and then plug into the equation. So let's do a couple of examples. So I want to find the domain. And remember that to find the domain is basically the equivalent of finding the equation of asymptotes. And when we're doing the domain, you want to find the equation of asymptotes, and it's always going to be in set-builder notation. So let's say you had f of x is equal to 3 cotangent of negative 2x plus pi over 10 minus 1. Okay, so how do you find the domain of this guy? Well, let's first start off with the inside. Remember, you're only looking at the inside. So I do not care about this 3. I do not care about this negative 1. All that does is change the range. The domain is everything that's in the inside. So right now we know that cotangent, the equation of the asymptotes, is x is not equal to pi k. That is the equation. So just how we were graphing it, we're going to plug that guy into the x. So we're going to have 2x, negative 2x, plus pi over 10 is not equal to pi over pi k. And now what we got to do is solve for x. So now what we're going to do first is subtract this pi over 10 over. So this is going to give me negative 2x is not equal to negative pi over 10 plus pi k. And now we're just going to divide this by negative 2. All of them. So x is not equal to a positive pi over 20 plus or a minus pi over 2k. So this is basically the equation of the asymptotes. Now remember, we want it in set builder notation. So we're going to write all x values such that x cannot equal to pi over 20 minus pi over 2k. And here, remember, k is an integer. Okay, so that will be the answer. Okay, not bad. Let's do another one. So what would be the equation of the asymptotes or the domain for this guy? Well, for secant, remember that we're only looking at the inside always. For secant, x is not equal to pi over 2 plus pi k. That's what we know. So what we're going to do, we're going to plug this guy in here. So we're going to have 1/4 x plus pi is not equal to pi over 2 plus pi k. So first what we're going to do is solve for x. So let's minus the pi over. So you're going to have 1/4 x is not equal to pi over 2 minus pi is going to give me negative pi over 2 plus pi k. And then how am I going to get rid of that 4? I'm going to multiply everything by a factor of 4. So you get a 4, you get a 4, and then you get a 4. So x is not equal to, this is going to give me negative 2 pi plus 4 pi k. Okay, this is the equation of the asymptotes. Okay, or not equal to. Okay, so now we're going to write the domain, all values of x, such that x is not equal to negative 2 pi plus 4 pi k. And here k obviously is an integer. Okay. And now let's just do one more. So let's say we have 0.5 tangent of 7x plus 3 pi over 4. Okay, so what would this guy be? Remember, we're only looking at the inside. So we're going to take that. The equation of the asymptotes for this guy is x is not equal to pi over 2 plus pi k. So we're going to take the inside, plug it into x. 7x plus 3 pi over 4 is not equal to pi over 2 plus pi k. We're going to subtract the 3 pi over 4 to both sides. So you have the 7x is not equal to, then we're going to put that into our calculator. So pi over 2 minus 3 pi over 4. And that's going to give me negative pi over 4 plus pi k. And then finally, I'm just going to divide by 7. So we got x is not equal to negative pi over 28 plus pi k over 7. All right, so this is the equation of the asymptotes. So now all I have to do is just find the domain. So it's going to be all values of x such that x is not equal to negative pi over 28 plus pi k over 7. And again, k belongs in the integers. Okay, that's basically it to find the domain. Not that difficult. Just make sure that you just look at the inside. The outside stuff is going to try to trick you. But this is basically how you would find the domain and the equation of the asymptotes.